I'll run
It
the
says we're recording. Yeah. Okay.
Cool.
So I'll start with my status on client work. I haven't done a lot. I got the PR open for the better stack traces, but it since I was just doing cargo check over and over again, I completely missed that Proc Macro 2 doesn't really like WASM32 because there's a generalized bug in Rust that the Rust flags you have to set to enable the unstable features from like nightly does not actually, if they set the target flag, which is how WASM builds work, it just ignores the other flags that include the config flags. So even though Alex Christian from the Rust core team both does WASM and does this proc macro 2 crate, they do not like each other and they're incompatible. So if someone knows how to get WASM32 to work, I can make the better stack traces work. Otherwise, I'm just frozen.
I mean, I haven't had any trouble building proc macro.
No, it's proc macro when you use the proc macro 2 SEM version exempt stuff, which is, he makes it that it's not a feature. He makes it a config flag because he wants everyone to know that it is not semantically versioned because it's in the nightly unstable stuff. But I can't get to work for WASM. Other people complain too, and those complaints then link to a Rust issue that's been open for like a year and a half. So I don't know if there's a workaround. Sometimes people kind of see like, oh, we have a workaround, blah, 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 but they don't really explain it enough. So I don't know if there's a way around this.
I mean, the feature
is
that
it makes
you
proc
were
macros.
using that flag for was just to get access to basically the location information that they're hiding, right?
Yeah, that's it. Because it just makes it so that I can make all the BIFs get their location with just proc metro that's an attribute macro that just says locate code, and it just like will know from that attribute point, you know, the function it's on. The other way to do it is to do a rules macro, but like it has to surround it then, and so it's kind of more annoying. Or the other way is you would put it right above, but you would have to put the line offset to like go +2 or +1. But if you have a comment, then it has to be plus as long as the comment is. So it's more work and error prone.
Like, what is the error that happens when it blows up on WASM32?
It just thinks the functions are undefined because the config flags just don't propagate. And I tried to turn the config flags into features by like forking proc2, and like it was just there's too many things that are just config flags because it has a build RS script, and I could not figure out how to get it to work.
Why does it just affect WASM?
Well, it would in fact embedded targets too. Anything you cross compile, and WASM is a cross compile target. It's technically anything that uses the target flag. So technically, if you use the target flag for x86-64, it would also break that. But the default builds don't use the target. They just use the assumed target, and then Rust flags work. But as soon as you use target, it assumes that for some reason Rust flags is only for your host target and not for cross-compile targets.
Probably have to use Xargo, like the cross.
Yeah, but
cargo.
This came up a while ago that with the time source thing where you can't actually use Xargo, but then Xargo is like, we're not really supported. And again, going back to Alex, he has also said Xargo is never going to be fully supported. Don't use it for WASM32. Like, don't do this. And so everything I found is like, don't do this.
Feature, can we just conditionally disable that feature for WASM32 and use whatever API to get a location is available?
No, because the other location API only works for rules macros for some reason. Like, there's no way to get the location of like an FN code to be like, you know. So it's like when you click the stack trace, it would just go to like, here's the native, here's the Rust function, and you would just know it. But like I said, there is a way to do this where I don't make it a proc macro. It just is more annoying to write the code because it doesn't just infer it. It'd be like off by a couple lines, but not that big of a deal.
Yeah, we should probably sit on that one until we can figure out the best way to deal with it.
I mean, of course, the other thing is that this might not be that necessary since we need to do stack traces differently with the compiled code anyway. It just was the thing to show that, look at
That's
us, we have better error messages
I
for
guess
right now.
I didn't really think about that. Yeah, that's going to be one thing for sure, is that the way that we generate and capture things trace wise is going to be different, uh, and better, I think. But um, I don't know to what degree that's going to impact the code that's already around. Uh, so just to give you an idea of what I've been working on. So I've been a little bit busy the past few days, so I didn't have as much time to work on this as I wanted, but I have spun up like a separate scheduler, like crate, runtime crate, uh, called just like minimal, that basically is designed specifically for the x86 target, um, and uses basically the approach I was going to use for doing context switching and everything like that. Way back when I was originally designing ARIA. Um, and so that part of it is pretty much borrowing as much of the existing Lumen runtime scheduler as possible. The parts I'm borrowing, I moved into, or copied rather, into like a runtime core crate. So the shared components of runtimes like this one. So ultimately what I'm envisioning is that, we have this big monolithic Lumen runtime crate, but the problem is that, like in cases like this where we want a target specific scheduler or other implementation details that are fairly small and contained, but require replacing, like the scheduler struct.
Why does the struct need to be different on WASM? Like, I get like how the scheduler starts needs to be different, but what else needs to be different for WASM versus like normal?
I mean, I'm not particularly talking about WASM. I'm specifically talking about x86 at the moment, but in theory, this could apply to multiple different targets. For example, on embedded, with a semi-real-time scheduler, the way that the existing Lumen runtime scheduler is written would not be appropriate. In fact, a whole lot of things would just need to be stripped out of the runtime, really. But that's beside the point. What I'm saying basically is that breaking up that runtime crate into like a core thing that has all the shared types, the function definitions that are primarily dependent on liblumen, alloc, and core, things that don't necessarily care so much about the scheduler. Um, and then each of the schedulers that are target specific would then get their own crates. I haven't done any of that. I'm just laying that out as a suggestion about how we could approach that moving forward. So like Lumen Web would essentially be broken up into like its scheduler component and then like all of the web API side of things. Lumen runtime would essentially get subsumed by the combination of like the core crate and whatever. Maybe we just move the scheduler out of there into another crate. Doesn't matter. But what I was working on was getting a scheduler spun up that integrates tightly with the generated code, the way that it is going to be produced, and wiring up a dispatch table. So one of the problems is that the scheduler, and really only the scheduler, but the scheduler needs to be able to map like a function, a module function arity to a function pointer so that it can call the entry function for a process. Once the process is started, it doesn't need to care about that anymore.
Well, the scheduler doesn't always care. Like, it always takes the code pointer. The MFA is just there for the stack trace. The only gotchas are the
Right,
spawn
I'm
and
talking
the
about when the
Y3.
scheduler starts, and for
Oh, you mean
example,
like the first boot? Okay, yeah.
right, yeah, the boot up process essentially, where the scheduler needs to start like the init.
I mean, your dispatch table
They'll
is just
define
going to be
that,
like
but
the
in
export
general, like
table, right?
Say that again. Sorry.
It's just going to be like the code export table, the one that backs apply right now, right?
Uh, I mean, it's more like a C++ vtable kind of setup, but um, it doesn't really matter. The point is that there's a way to map a symbol efficiently to a function pointer that can then be invoked. So that part of it is basically done. I need to test that the dispatch stuff works, but that could be used for two purposes. One for spawning the init process, and then the other is the general just apply function would
Yeah.
allow the scheduler or the runtime rather to be able to map a
So
symbol back to a function pointer.
how do you turn like two atoms and an integer into a lookup into a table? Because like I just did nested hash map, but like how would you do that? Did you just use like the atom indices as just numbers, and then you because it would seem like it'd be really sparse, or like did you somehow
Oh,
map those out into one
I'm not
number?
declaring like an array, which is I guess is how more of a C++ vtable works. But yeah, it would be backed by a hash map, so it's the same essential function there, except for I'm basically optimizing it by using the symbol as it appears in the code. So um, the way that the symbols get generated for functions are sort of like the Erlang style function name. So module colon function slash arity.
Oh, okay, okay. So you don't need three things; you could just have one. Okay, yeah.
Right. And so I just generate a symbol for that. And then the lookup is just finding that integer value in the hash map. And then that pulls the metadata out that has like it's a pointer to a struct that has the name of the module, the function name, the arity, and the pointer to the actual function. So essentially doing dynamic dispatch is a lookup in the hash table, a pointer offset to the function pointer, and then invoking or transmuting that into the right signature for that function, and then calling it with the arguments that are already on hand.
Do you have an idea of like how do you like do you put everything that's live in the dispatch table, or just the things that you know you have to do apply style calls for?
When I'm doing cogen, each module that I compile, all the symbols that get generated, so function visible functions, uh, get collected. And so at the end of compiling all the actual modules, I generate two additional modules manually. One is the atom table, and the other one is this symbol table. At runtime, when the core runtime shim kind of invokes everything, the first thing that it does is it initializes the atom table and then initializes this dispatch table and then calls into the entry point for the scheduler.
And you're
Scheduler then has a fully like seeded atom table and symbol table to work with.
and then the dispatch table is like by the time you generate what should be in the dispatch table, you already know what's dead code eliminated, so you don't accidentally keep something alive just so that you can put in the table.
So that's something I need to add to the linking step later,
Okay.
is going through and trimming that. But right now it will not trim those symbols.
Okay,
So
because that's how I ended up with the export system that the current runtime has. Is that way I had to explicitly say what I was exporting to the dispatch table, so that I didn't keep stuff alive that we didn't need from the BIFs or the Lumen web stuff. And that's why those things are like I want to be in the dispatch table. Otherwise, they don't get added, and that way it lets the code still stay dead.
probably the best way to do this ultimately is to gather all the symbols, perform the initial link of all the object files, but not like a full link yet. Diff the list to trim out all the things that were dead code eliminated, generate that symbol table module, and then link that into the final artifact.
Yeah, you'll need
But
some way to keep track of this is the live because of the applies though. Because but besides the scheduler entry, we have other applies. And I mean, obviously, if the EIR optimization passwords of the LLVM can eliminate them, doesn't matter. But if there are still live apply threes, then it would matter that we have a mechanism to keep them alive.
right, which is why I'm not particularly concerned about it by default having all those symbols kept alive, because the use of apply means that they effectively should be there anyways. Ultimately, we're going to need to figure out how we can, um, either filter those out, statically resolve those applies where possible, using some of the tricks we've discussed in the past. In fact, that's where I think the vtable from idea from C++ works really well, is we can actually use that for behaviors. Rather than trying to monomorphize the code, we can just use a vtable.
Yeah, I definitely think that since we're more size conscious than Rust, that monomorphization is a bad path because I know that seems like the biggest thing with fighting in the Rust WASM stuff is like it monomorphizes way more than you want it to, and then you end up with code bloat.
I mean, the useful aspect to it is that you can perform a lot more optimizations when you do that approach. So the amount of code that gets generated might not be that much more, if a lot of redundant stuff can be stripped out. But in practice, I'm not sure how likely that is. So I think, yeah, it's not important for us to pursue that for any particular reason. I just was initially thinking that that would make the most sense. But as you pointed out, if size is more of a concern, then B tables make a lot more sense. And just in general, being that Erlang is a dynamic language, supporting some of that dynamism, even in a compiled binary, could be useful. Especially if we down the road ever want to support running a shell inside the executable. Um, we need the ability to kind of like compile on the fly and call things that were not necessarily considered live during compilation. Um,
Yeah, I think in shell scenarios though, we don't have to worry about size as much. So I think it's fine to like be
yeah,
big
yeah,
then. I mean, the
that's
same thing may come up with like our better error messages approach because like the WASM for spawn chain is bigger now because of the better error messages. So like we may have to have a mode where we get rid of better error messages in a release build for that reason.
or at least provide the option,
Yeah,
let people choose whether they get better errors or smaller size.
yeah.
Uh,
Because like
I,
they're really helpful when you mess up, then just getting bad arg and being like, which one of the five arguments was wrong, Erlang? So that's better. But if you think your code is correct when you're about to ship, it would save you space to not have them that way.
So I mean, on the uh, client side world, many of the frameworks, they'll have a production build that'll be like stripped out as much as possible, to save the space. And then they'll have a debug build that will include a lot of the, like either debug or symbol information or any type of uh, additional things in that build that bloats the hell out of it, but it's good for running for QA or in staging environments in order to determine those type of issues. My inclination is that production builds, especially for client side assets, should be as stripped as possible. Like in production, you're not necessarily going to be going into the debugger to check things out. However, we need to be certain that whatever is being stripped from production does not introduce like basically branches of the coding at that point, where now it's chasing down something that exists in production but wouldn't exist in other environments.
I
yeah,
I think mostly we can get away with it by just making the strings all the same. So like we will still pass through anyhow, but we wouldn't have customized helpful error messages, and so that one string would be there instead of a table of like 100 or so strings. extra strings that we're getting to having all the very clear error messages with the argument name. Like that's the benefit we got with better error messages was instead of one of your arguments is wrong, we tell you this one is wrong because it's not an integer, or it is a tuple, but it's not a two tuple. Like it is very clear what is wrong, but that means there's a lot more text just sitting in the .wasm data now.
Yeah, you got to think about like who are the primary users of a production build though, right? So like well over 99% of the people that are going to be executing this code aren't going to be opening up console to check out if something goes wrong. They're just going to be your casual users. And so you have to kind of err in that direction. And that side of the conversation should really be on, okay, how do we get these assets to them as fast as possible, which means reducing their footprint size.
Yeah, and mind you, this bloat was without the compression. Like I didn't go through the WASM op steps that I had the last time when we tried to shrink the file. So it could be that it is just text. It probably compresses well.
I mean, there's
But
degrees
of course they'll
of
expand. So
support that we can add to, like it doesn't have to be all or nothing. You can do release builds with assertions enabled, for example, so that if something unexpected does go wrong, you at least hit your assertions. And that cuts down a lot of the extra debug formatting stuff. So even if you don't have any of that, you still have some helpful errors. But for people that really just don't want any of that at all and are okay if it just completely stops dead, then they could opt out of that as well.
It might make sense to have a system where every error just have a transparent system for it in the code, but every error maps to like a error code or something, and then that automatically gets mapped to the message when the text tables exist. And
yeah, I think that's possible because we could mimic the way. So I now understand how proc macro 2 kind of works because I didn't dig into it. And the way they do it is whenever you ask for the call site, it's actually building up this map in the background, and it resolves those once the macro is done somehow. And so we could do the same thing where like every time you call the macro that like records this is the error location, it would assign it a new ID, and we could just be like, here are all the error codes, and we would have some way to map them back. And
is there going to be a kind of like a choke point in the logger where someone could say, hey, I'm going to add my own logger to this? Because a lot of these client-side apps, they'll use a service, and any type of error that occurs, they'll basically just log that error to that service.
Rust. So right now the better error messages
library, but I don't think we need to support that out of the box, and not for the Rust side.
No. I'm not suggesting that we support the idea of like an interface for the system, just a choke point that someone can swap something out.
No,
with their own thing.
Right now the backtraces just go through system IOputs, which is the low-level writing to whatever you can write to. So it's either standard out or console. I mean, we could make it not be IOputs and make it be something else that you could shim in something else, because that's sort of how panic works in Rust. That's why we're able to panic to console, is because the Rust core team made that hookable. Like you can substitute the function.
Yeah, that's what I was suggesting by having the ability to link in a library that just implements the log creates interface. And then what we can do at startup is just check for any implementations of those and initialize them.
Yeah, the one thing, like from an Erlang perspective, is technically that stack trace is supposed to be going through the driver system. Okay, we got 10 minutes, so let's cover the one thing we had to do.
So, yeah, I got. I'll just let me run this part, Luke. So the question is around FOSDEM and whether or not you have everything that you need for FOSDEM.
Right now I don't know how to run Paul's code, like his test module, so I don't have anything. Like I know you pushed up the code, Paul, but I don't know how to run it. So if you want me to show it off, you need to give me instructions.
Yeah, I'm basically working on the scheduler part of that, or well, that's what I was talking about earlier, right? I had the scheduler part of it pretty much done. I need to be able to test that So the parts that I've been working on, like this morning, and well, again later tonight, are the borings for those features that I've essentially added support for in the scheduler. So the context switching, the yield and return parts are now exposed in scheduler. And so I need to add that into the lowering for functions so that at the top of the function, I check reduction counts and all that. Once that's in place, then I think pretty much have everything that's needed. And we'll have to do some testing. But at that point, I could give you the instructions on how to set up an environment that matches mine.
Okay, well, I I
When
leave
is
the private
your-
airport in like 24 hours. So like anything you tell me after then, I'll get Wi-Fi on the plane, but like it has to be stuff I can do transatlantically and over a VPN in Europe. So like there's not a lot of time. I talk about on Saturday, but I will be already traveling in 24 hours.
So the first thing to do that is really the only blocker here for you, or not blocker, but thing that you're going to want to make sure that you have ready. Let me just make sure that I have this pushed. Yeah, so check out the Lumen branch of the LVM project repo and the Lumen org. Like,
Okay, so there's the Lumen branch in our forks. Okay.
yeah, it should be the default branch.
Wait, I thought you pushed a release
That was
for
a while
LLVM,
back.
didn't you?
So the first thing you'll have to do is rebuild LLVM using that. And I can give you the exact instructions on how to do that. Well, the instructions for you are to cd into the root of that directory and then just run make LLVM. And it'll do everything for you. But that assumes that you have Ninja and Ccache installed.
I have Ccache. I don't know if I have Ninja though.
Just brew
did.
install it, and that's all
Yeah.
you need.
No, I was trying to think if I can't remember if I used Ninja on this laptop or was the previous one.
Just in general, it makes the LLVM builds go like 100 times faster, so definitely worth it. But yeah, if you do just run make LLVM, what it will do is it will install the LLVM build into XDG data home, which defaults to .local share in your home directory if it's not already set. So it'll be like .local share LLVM Lumen. So that basically supports having multiple installs side by side. But
Okay. And
I have to jump off. I just had one quick question. Someone asked me if CLI will be supported or can be supported at some point with Lumen.
yeah,
Apparently,
essentially that's what I'm working on right now as the first step of this is a scheduler that just runs on like a MacBook or Linux box.
okay.
Easiest and most straightforward to get built. And then
It seems like someone at Nubank, I'm not sure if they're formerly Platform Attack, but they're doing a lot of CLI work in Python, and they're kind of swearing that they could do it in Elixir.
yeah,
I mean, we would do it anyway because we want to support like the first things you do in most Elixir books, and like a lot of them show you how to make command line stuff, even though it's not normal in Elixir or Erlang, and so we would support the normal system
Like
RT
scripts?
stuff.
yeah, it's a lot easier to get us the CLI stuff for like x86-64 done than some of the additional WebAssembly trappings.
Yeah, the WebAssembly is weird because WASI's super unstable. So as long as they don't want it to be a WASI command line thing, I think we're fine.
The major thing is that once we've got all this stuff done for x86, then it's clear on how we clean that up or port that stuff to the existing like WASM scheduler and all that jazz. The main
Okay,
thing.
I gotta jump off. Thanks, guys.
Yeah, we'll see you.
Bye.
So, Paul, I have the old LLVM installed. Is there anything I'm going to have to do to make sure I use the one I built?
No. So when you build things in our project, you have to specify well, I have a make file there. You'll see in the root of the Lumen.
Oh, the LVM export. I'll have to redo that again
You
make
won't
sure-
have to type any of that yourself.
if I
That-
use the make file.
I
Though.
have the make file.
Okay. I mean, I haven't been using the make file, so.
Yeah, no, it was like outdated and didn't need to be used. But with LVM in the project, I put that in there so it simplifies things for everybody.
But
It's not
when I
necessary if you're not
use,
building the cogen crates, but for anything that involves building the cogen crates, it just doesn't make sense.
but when I use the make file, I use the make file in your branch of Lumen on the CodeGen branch, right? And that branch automatically pulls in the correct version of your forks of EIR, right? Because I already saw that you had the rewrites for the branch names, right?
The patch and the cargo.toml, yeah.
Yeah. Okay.
So what this does though is if you're following the installer for LVM,
Mhm.
I was just describing, the defaults for this makefile use that. So it will pick up that LVM installation and set up all the environment stuff automatically for you.
Okay.
You don't have to do anything. And then it has targets for building either dynamic or statically linked executable. And the one that you'll want to use is I think you can use either one. I believe I fixed the issues with that, but I would just build the static one for now because there were some issues with dynamic linking. I think I got that sorted, but what I found was that apparently something breaks with the dynamic linking with MLIR because of how they're doing like runtime type information. Something gets lost. So like is trying to check equality of some types and it fails because it doesn't dispatch correctly. Anyways,
Yeah,
so
that's actually where I got stuck on the proc macro too. It said the two types had the same name but were incompatible. So like that's where I got stuck.
Interesting. Oh, that is weird. Yeah. Huh. Yeah. So the build dash static target for in the Lumen repo is the one that I run to build a compiler.
Okay.
So with LVM built, you can run that. It will generate the executable. Right now, at least with the state of that branch, after I pushed it, when you run it on a file, it dumps a bunch of debugging information of like the cogen that it's doing, the MLIR cogen. And then if it probably won't finish because the state of that, not all the lowering stuff had been wrapped up on the tail end of it, but you know, you can at least verify that it goes through all the stages up to like linking basically. But what I would do is just make sure that you at least have that much. I can also give you, 1 second here. Oh yeah, so when you run that build static target, it builds and installs like a package, a tool chain for Lumen in the bin folder.
Mhm.
And symlinks the main Lumen executable for the host target into bin/Lumen. So when you want to run the compiler after building it, it's just bin/Lumen. And then to get help, you can just do like help compile. But the shit. I was going to send you the invocation for the compiler that I was using because you may not know what all